Let's see. All right. Yeah. So it's known that the average age somewhere is 30-some, some little island. And the standard deviation sigma is 10.19. Right? We take a sample of 49 people from this island. What's the probability that their average age is more than 40? Now my first question is, gotta be really careful because I'm going to ask a few conceptual questions on this test. Like here, I'd say something like, why are you allowed to use a z-score chart for this problem? Uh-oh. That's the question. So by that question, I pretty much said you can't. Which means this has to be what kind of distribution? Normal. Do I say anything about normality here? So the average ages on the island, that might not be normally distributed. It might look freaky. It might look like alternate universe Florida, right? But what distribution am I using here? What makes this work? I'm not using the distribution of individual ages. This question is so confusing, I know. Oh, shit. Am I talking about individuals? Am I comparing individuals to individuals here? No. Group of people. And what's got to be true for samples to be normally distributed? The sample size has to be greater than 30. Sample size has to be greater than 30 in order for all the means to be normally distributed. The individual ages could look freaky as shit. But if I plotted all the samples of size 49, they would come out to be normal enough. Do you guys get the distinction there? I'm not saying that the distribution of ages is normal. I have no freaking clue. But since that sample size is more than 30, if I plotted all the samples possible, they would come out normally distributed. I love you guys. I love you guys. So that's why I can eventually use the z-score chart. Z-score chart requires us to have a normal distribution. If I don't say it's normal, the sample size better save our ass. If I picked one person from this problem, we can't do shit here. I don't know. Shit, I don't know what the freak the thing looks like. How could I possibly tell? I have a chart that works if it's normal. That's what saves our ass. The fact that we're not talking about individuals. We're talking about groups of 49. So what am I going to have to do before I do any calculations? What about the standard deviation? Change it. Why? Because this standard deviation is good for individuals. And I need the one that's good for groups of 49. Do you guys get the idea? If I take a group of 49, their average age should be close to what number? 37. That means more of my group should be closer to the average. The standard deviation should get smaller. We know exactly how much smaller it gets. How much smaller does it get? Poor little dude. What's the formula for that? Yeah, standard deviation divided by square root of n. So whatever the hell, 10.19 divided by the square root of, where'd it go, 49. 10 divided by 7 is like, what would that be, Jeff? 1.4 something? It's 1.5 something. Ha ha ha. Sorry. It's my one skill. So I got to show off every night. So 1 point who? 4, 5, 6. Neat. I like it. Okay, now finish that problem out. And while you're doing that, I'm going to run back to my office because I'm in state. That really sucks, Jeff. Pretty sure I left him back there. I'll leave my camera running so I can hear what you guys say about me.
So we have all the numbers except so we can make it out. Only 187 is 22. So it's 1,000 equals basically just plugging in the numbers. For this one? So this is PFA plus the other side of it. Minus P. And we found P and D in the page, so we can use this number.
I just couldn't say that. All I can think of is I did that at my friend's house with drinking. And then in the morning we went down. We all jumped in. But it's like that. We're probably not even close. Well, now we're still hot weather. It's still I come out. My family's probably supposed
But I can understand everything. I can understand
Yeah.
my county my county is parents. So my parents
I didn't even print them out. All right. So you guys done? Hopefully you're done. What goes in the middle? You guys remember this problem? What goes in the middle?
40. No, 37, sorry.
37. And then 40 goes in there. I want greater than 40. So now, how to make the z-score? I would do 40
minus 37 over 1.5.
Is that cool? If I would have asked pick one, we would have used 10.19. To be honest, we wouldn't have been able to finish the problem because we don't know it's normal. But big enough sample, I used the changed standard deviation. What do you guys get when you do this? Like 2.08. You guys look. That's pretty good. Come on. 2.06. And then whatever the hell that is. What do you get when you look that up? 0.9803. Is that what you guys got? And then, so the answer is going to be
10197.
I like it. So just under 2% chance that you pick a group of 49 people with an average of over 40. should be really unlikely to do that because any group of 37 should have an average close to, any group of 49 should have an average close to 37. Yeah.
You said you were going to ask a question about why you think this is useful. So the answer just saying because the sample size is more than 30.
Yeah.
That's it.
N greater than 30. And what's the theorem that comes from? Sounds like chicken, lettuce, tomato. Chicken, lettuce, tomato. CLT. The central limit theorem. The CLT. Central limit theorem.
I can say that.
No. But that's the theorem that says this. The central limit theorem says the larger the sample you take, the more normal the means become. If it's greater than 30, almost every distribution becomes normal enough. Yeah, the wind is going to try to come in. It says the mean stays the same, and it says the standard deviation changes like this. That's what the central limit theorem says. I like it. Of course, this is less a theory class and more an application class. That's cool. Okay. So any questions on that idea? So what I want to do is I want to unleash you on this. One side is Chapter 7 review. So you might want to start there. And the other side is a little bit of Chapter 5 and 6 review.